Assalamualaikum warahmatullahi wabarakatuh. My name is Alif Haronudin Ismail and this is my water level controller. The abstract. So, as you all know, we can't monitor our water tank level in our houses. This makes hard for us to maintain good water level and know if the pressure is enough for the water to flow. The system created is a combination of Arduino software and hardware as our main processor. With the help of advanced technology, everything is at your fingertips. The water level controller project consists of a main tank and a reservation tank. This is the reservation tank and this is the main tank. The reservation tank acts as a tank that stores most of the water, and the main tank is an analogy of a house tank. Whenever this tank reaches below its minimum level, the pump will act by pumping out the water from here to here. So with the phone alone, you can monitor the water level in the tank as long as you have an internet connection and you're good to go. The introduction: mainly, water tank in our houses need to be placed in high places in order to have a good water flow, which is good thing that we don't need to see that bulky water tank. But looking at the downside of it, we can't monitor our water tank level, which is hard for us to indicate how much water it has in this tank. This also affects farmers who have a hard time on watering their plants and farming, since they need to do it manually. So referring to the things that need improvement are firstly the tank. The tank needs to be monitorable to know its level. We can solve the issue by applying a measuring sensor, which is I use ultrasonic sensor. And then next is the pump. The pump needs to be controllable automatically and manually. The water float ball valve, which is used in our toilets, is not efficient as a pump and indicator, as it is easily broken and cause water leakage. So the problem statement here is, this day it is hard for us to indicate and monitor our water tank level. We can't monitor because we are using traditional float ball valve. This method is weak on indicating water level, making when there are no water supplies in the reserve tank, water shortage will occur. We also can see in flood warning system, people sometimes receive late warning and not enough warning system implemented. The objectives. The first objective is to ensure users can monitor their tank's water level. This can be done by installing a distance measuring sensor. Secondly, to automatically pump the water to another tank. This is by implementing conditions in the pumping process. And lastly, to control the pump manually using smartphone. The characteristic of this project is first, it is reliable. What it meant by reliable is the measuring sensor. We need to use accurate measuring sensor. Secondly, it is solid. Solid means that the pump and the mechanism to flow water needs to be strong. And lastly, flexible access, which is control the pump and access the data anywhere, anytime by using our smartphone. So the operation. So firstly, as you can see, the reserve tank is in almost full. When the tank is below 20%, it will start filling until it is 80%, about here. It is 50%, and then it reach 80%. Then it reach about 80% to 100%. So it will stop around this level. So this is when the manual function starts to work. So when the automatic stops, so we can use this as a manual control of the pump. So the water starts filling until it reach 100. On, switch on. It will automatically stop. So this is an analogy of our house tank. So when we deplete water, so when it reach 50%, it will start filling back all the way to 80% or 100%. So in this case, it stopped in the 80% level. So let's do it again. This is an indicator to the pump status. If it's green, then it is turned on. The water pump is turned on. Let me explain the circuitry. So first, this ultrasonic connects to the main board. This is the main board. The main board consists of an LCD. The LCD, which is it indicates the water level of the reserve tank. This is the reserve tank, and this is the main tank. Then looking inside the board, you can see we have an Arduino MOS, relay, and some connectors. And then this is the ultrasonic for the reserve tank. This is the water pump. So that's all for my demo graphic for the project water level controller. Okay, so let's move to the impact. So gives benefit to the following people, such as house owners to monitor their water tanks, for farmers to automatically deplete water to their plants and breeding animals, and lastly to authorities to implement in factories or other safety system. So let's take a look on the cost. Firstly, I use 2 ultrasonics which cost 10 ringgit, and then 1 Arduino MOS which costs 30 ringgit, 1 micro submersible water pump 5 ringgit, LCD 5 ringgit with its I2C 3 ringgit, the storage box or the reservation tank is 16 ringgit, and the water bottle or the main tank is 5 ringgit. The improvement and suggestion, there are a few aspects that I find great to make this project even better. Firstly, measuring sensor. We can improve this project by replacing the ultrasonic with a more accurate reading. Secondly, the actuator, and lastly the model. This model has not quite have the safety because it has wire. So by improving of the electronics waterproof in order to prevent faulty and malfunction in the process. So lastly, we came to the conclusion. This idea can be implemented in a larger scale of use for industries and farm. As example, the conclusion is by doing this kind of projects given to students, we can invent brilliant ideas on making change to the world and assure it for a better place. That's all from me. Assalamualaikum warahmatullahi wabarakatuh.